Hi everyone, I'm Ron from Business Hong Kong. Welcome to Business Hong Kong YouTube channel. This is our second MicroPython tutorial for W55MH32, and today we will talk about ADC. If you wanted to know more about how to install MicroPython in W55MH32, you could watch our short videos. The links will be in the description below. About the ADC, not all the GPIO pins has ADC features, so we need to go back to the w5500.com to check which pins has ADC. In this webpage, scroll down to the bottom and you can see the pin description. In the middle of the pin description, it shows all the ADC, most of the ADC pins. There will be around 10 or more than 10 pins. And today, we'll focus on PA4. This is our testing pin for this tutorial. And we will test ADC with this pin. After that, we could talk about the board. The board that we will test today is our W55MH32 LEVB that has been connected with a potentiometer that has been powered using the board's 3.3 volt in the ground, and the testing pin has been connected to PA4. Okay, right now we could do some testing with using Python script. Okay, in Thorny, we need to test the MicroPython using ADC. It requires two main modules. The first one is the pin to activate the PA4 pin, and the second one is ADC to get the information using ADC. So from machine import ADC, pin. And we need to import a timer, a software timer that this time I will use. And then I need to create a variable for this ADC. So port that represent the potentiometer will be equal to ADC. And then I call pin. I activate PA4. And then close brackets. After that, I need to create a while loop to continuously to get those data, and then raw the variable to collect the data from the potentiometer will be equal to pot.read_u16. This is a function that is in ADC that will collect a 16-bit value from the ADC. That means it's directly to get the data from the potentiometer using ADC. After that, I will create a variable to convert this information to more meaningful information. The first one will be voltage. So voltage will be raw divide 65535. That is the total of the 16-bit data, and I multiply it by 3.3 volts to get the actual voltage. After that, I will create a percentage to have another version of display. Also, I need to divide it by 65535, and then I multiply by 100. After I converted this information, I could print it out to show this information. So I will use print and then voltage is equal to brackets voltage and then 4.2F to set the decimals correctly from the float value, and then volt, comma, percentage, also percentage, and then colon 51, and then percentage, close bracket, like this. After that, we could use time sleep and set to 0.5. This means every 0.5 seconds delay, and then it will collect the data afterwards. Right now we could try to run the script. You could see right now it's in 3.3 volts. Oh, there's some mistake. So I will just right here, I forgot to put the F as a float, converted it correctly. So I run the script again. As you can see, the voltage right now is turned to the maximum, so will be 3.34, and the percentage will be 100%. So I slightly to reduce the value, the voltage. You could see the voltage and the percentage is decreasing. So go to the lowest point, there will be around 0.06 volt, and is around 1.7%. There will be a slightly difference, but this is how the ADC works. We will continuously to create more kinds of videos based on W55MH32 in MicroPython. Thank you for watching.